Hello everybody, my name is David Thompson. I'm responsible for marine solutions at Aviva. Aviva, of course, being a leading supplier of solutions for the capital intensive industries, including shipbuilding and now ship operations. What I'd like to do today is to present to you a presentation I gave recently at the COMPIT conference. That's the Computer and IT Applications in the Marine Industries Conference. That was held in physical conference in Mulheim in Germany between the 9th and 10th of August. And yeah, it's a conference which is relatively intimate, about 50 to 60 people normally. Because of COVID, of course, significantly small. I think we were 26 physically there. And it's a very good conference for industry, both shipbuilders, ship design companies mostly, and academia to come together to, of course, exchange ideas, present research projects. So coming from a software vendor like Aviva, we sponsor this conference. We believe it's very important for us to have this contact with academia, but also to present our sort of more forward looking ideas, taking our experience from the industry, from the many shipyards that we work with and now ship operators, and to bring this back into the industry, because we think this is a very healthy thing to do, to exchange ideas. And of course, that's particularly important these days because industry is going through I think larger disruptions than normal. So it's always kind of going through change, but there's of course the IMO regulations, or not really thinking about IMO. It's more to do with how do we get to zero carbon? How do we fundamentally change the way that ships are operated and propelled, the fuels that they use, so there's sort of major changes going on. And of course, the backdrop to all of this is rapidly commoditized technology like machine learning, the ability to store large data sets, XR technology even. All of these things are developing quite rapidly, and of course everybody's looking at that buzzword, digital transformation. How do we change the way we do things? So COMPIT this year was, as always, very interesting. A lot of papers on machine learning, several PhDs using machine learning instead of your more traditional empirical methods. A few papers on big data, a few papers on marine operations, especially sort of human factors. These kind of things always come up. And for me, as a representative of Aviva, a vendor at this conference, I decided I would really like to talk about the convergence of IT, so information technology, and OT, operational technology. Of course, that's something that we're looking at just now because we have a background in developing IT applications for the shipbuilding and the process plant industry. But since we acquired the OSI Soft business, we are really in the operational technology arena as well, and in pretty much every industry under the sun. So I've been personally looking at how operational technology works in vessel operations and in shipyard operations, and I wanted to present how we're starting to think about the building blocks of digital transformation with the tools, of course, which we have. So I'll jump ahead and I'll present basically as I've presented at the conference for you. So I'll begin by looking at the current situation. In the paper that I've written, which is freely available on the COMPIT website, I've written about the current situation. So I'll give a very brief summary of that in the presentation. And then I'll talk about these core building blocks of digital transformation and perhaps expand a little bit more on these in this YouTube version of the presentation. And then I'll talk about how companies are using these building blocks to build a better maritime industry. Again, the presentation is sort of supposed to be 20 minutes. It'll be slightly longer in this form, but the paper has much more details about all of these topics. So in the paper, I talk about the current situation, and many people talk about these different revolutions. So the industrial revolution, the internet revolution, if you like, the digital revolution, and now Industry 4.0. And the interesting thing about these evolutions of productivity, as I like to call them, is that there are building blocks which get put in place before these evolutions of or revolutions of productivity take place. So of course the Industrial Revolution, was the mechanization of producing things, and essentially to do that you had to have readily available iron or steel, and you needed to have a power source. So basically the commoditization of both of these kind of raw materials allowed us to do the Industrial Revolution. So we were able to get coal readily, able to transport it around, able to use that to turn it into steam power, back in the day, or eventually into electricity. Electricity, of course, another example of a building block. If we fast forward to today, we've been through the sort of first digital revolution where we've digitized many of our processes, but we're now in this stage where we're basically have data as a commodity. So data, we're able to generate data both from business processes, but also from operational processes through sensors, through technology like the Internet of Things. So what do we build on top of data? And that's where we are in terms of current situation. But if we look at IT, so summarizing very much what's going on in IT, we way back in, I think it was 1912 or something like that, we had Henry Ford who looked at the meat packers and basically said, I think I can change the way that we build these automobiles. And he basically introduced the first or the most famous mass production line that took building a Model T Ford from, I think it was 12 hours down to 1.5 hours or something like this. So a major productivity leap. But through that process, he affected, of course, the way that we work today. So we know now to take a complex problem and to break it into disciplines or individual streams of work. And this is how we work most efficiently as it is today. So, of course, the IT technology that supports the marine life cycle today is essentially broken into these vertical divisions of labor. So we have design, procurement and planning, manufacturing or production. If we go into operations, we've then got asset management, and then crew management, all of these other kind of disciplines in the operational cycle. So we end up with this silos of information. So I hate to use this well-used phrase, but that's why we have silos of information, because software companies, or basically people realized there was a problem in terms of how do we design things. So software companies created design software, which today we generally refer to as CAD, computer-aided design. And the same for the people dealing with the finances or the material management and procurement. They developed ERP systems and so on and so on and so on. So these are vertical applications. They serve each department or kind of business process very well, and they've basically digitized those processes. But the information that is kind of generated in those vertical silos tends not to be very well connected, and it's quite hard to move that data around. So there are companies like ProStep, for example, that specialize in integrating or joining together these things through interoperability. There's also now software approaches trying to join together the data of these vertical IT applications. So that's where we are today for IT. And for operations, a similar thing has happened. So when we talk about operational technology, we're basically talking about, so digital technology, let's say, we're talking about sensors on machinery, the ability to use that information from a sensor to control, first of all, that machinery. So a dynamic control system, and this is where we get things like, I think it's product logic controllers, PLCs, PIDs, and all of these things that basically will take an input from a sensor or several sensors, apply a little bit of logic to it, so a tiny bit of computing, and then provide an output for another thing. So the classic example is fuel-air mixture on an engine. So you've got sensors which are measuring the fuel flow and the airflow, and then you're able to determine perhaps through another temperature like cylinder head temperature how efficiently this engine is running, and then you will have some controls which will balance out your fuel-air mixture. Or in a big main engine on a ship like you can see here, or this is a diesel and gas turbine propulsion system, you're going to have some you're definitely going to have some control system which is taking inputs and balancing the throttle inputs and the fuel injector inputs on these engines to make them run efficiently. So that's where operational technology kind of began in the marine industry, in the shipping industry, in the engine room, in the engine control system. It's now spread into, of course, the bridge. We've got dynamic positioning systems. We've got advanced autopilot systems. So those areas of the vessel actually have fairly advanced operational technology deployed, but other areas don't. So pumps, a variety of other things and systems on board vessels are simply not using operational technology. There was no real need to in the past. But what we're seeing at the moment is that there's a huge incentive for shipping operators to deploy operational technology. So generally it's sensors and what we call data historian to understand what's going on in the vessel as a whole. So of course the pumps, air conditioning, fans, in of course cruise ships, there's quite a lot of operational technology going on to manage all the automation around the environmental conditions for the passengers. But each vendor, so each OEM, is essentially deploying their own operational technology, and the ship owner as such doesn't really get this nice overview of the operational data. So we end up with this situation here, a little bit like the IT situation where we're developing data silos. So the main engines might have a data historian running, or even a box, to send this data back to shore via the satellite connection. Generators. In LNG vessels, you definitely have a system for the cargo management. You have, of course, various systems in the navigation area. So it might be a Kongsberg, it might be a ABB involved in this. And all of these are creating data silos. So each OEM has their own operational technology, and it means that it's very difficult to get an overview of the information. It's difficult to share information effectively. So it's basically an inefficiency generator. So that's where we are today with operational technology. Both of these siloed vertical IT applications and the siloed operational technology means that it's hard to manage change. So what do I mean by change? Well, in the engineering space, you change something in design, you need to propagate that change to procurement and into production. And that's still a challenge in many organizations today. It's not very well handled by those vertical applications. You generally can result in poor quality data because you might have duplicates of information, you might have overlaps, you might have just information that you're not aware of because of these silos of information. When we think about more futuristic scenarios, it's very hard to know who owns the data and where the master is. So when you think about the engineering process, some information might be in your design system, it gets passed on to ERP and then into your manufacturing system, and nobody knows where to go to change this data or to update it. So that's a problem. And if we think about operations, we've generally got a problem of who owns this operational data. Is it the engine manufacturer? Is it the class society? Is it the ship owner? And these are questions which have actually come up in a survey which we've recently done with IMAR Est, which you'll see in the next few days. And the most important thing is that when you have these fragmented places to put information, it's very hard to do a more general optimization. So I think we're reaching the limits of how far you can optimize these separate component parts of IT and OT. And a little story here. This is from my personal observations. I used to work for IBM where I was a consultant, a sort of IT consultant, or we call the IT architect, I can't remember. But basically, companies have found that they've kind of reached peak performance as it is. They've digitalized many of their processes, but they're not really making any step change. And everybody wants to make that step change of productivity. So my experience of working with a large cruise ship builder is that you go in there and you say, okay, show us the processes that you use to build the ship. Nobody has them documented. So you you go into a series, in our case, I think it was about 6 months of interviews, where you interview everybody who does know how to do the job, of course, but you find out things like people are still doing things manually, or in the worst case, people are doing 2 different departments are doing the same thing. And you can kind of ask them to say, where do you think your problems are? And they literally do not measure performance. So they can't really tell you, we have a bottleneck here, or we have a duplicate here. That's why they bring in the management consultants. Management consultants can identify those bottlenecks. They can make, I would say, point improvements. So they can say, okay, if you digitalize this process or get rid of this duplicate process and do this on the basis of a 3D model, you will save, this much money. And that kind of stuff works. That kind of optimization is possible today. It's just simply looking for holes where you haven't digitized the process. But it's very hard to do that at a broader scale. And I've not seen any major step change in productivity in shipyards by applying management consultancy to it. So how do we go forward? Well, luckily, things are changing, and continued focus on improvement from chief technology officers, chief operational officers, and all of the people involved, in the process. They know that it could be better, but also the development of technology that supports our way of working is really pushing us forward. So there's some fundamental changes in the way that organizations think about their IT technology. Quite simply, we're going from IT spaghetti on the left-hand side towards a much more holistic way of thinking about computing. You could almost say, the end game perhaps is the metaverse, but there's probably a step in between there. So we look at the left-hand diagram. This is coming from your typical server client architecture you find in pretty much every enterprise organization these days. You have several large servers. You're running all of your main, information systems on that, your CAD, your ERP, maybe a PLM system, maybe a manufacturing execution system. And you have point-to-point integration. So you're typically spitting out a file, reading it into another system, and it gets extremely hard and extremely costly to manage all of this stuff. So where are we today? Where are we going? Well, we're generally thinking about this problem in a different way. So first of all, we're trying to move everything where appropriate to the cloud. So take advantage of cloud computing, take away some of this infrastructure, IT cost and overhead and complexity, move it to the cloud. Moving away from point-to-point integration and trying to use more advanced integrations, more APIs, for example, or more streams of information to share information in a more holistic way. And of course, moving to the cloud is a good way to do that. On the right-hand side here, we have a picture from Gartner. So Gartner basically saying, if you want to be a truly digital business, they analyzed these pure digital businesses like Amazon, Uber, Spotify, these kind of companies that have a native digital business. They look at things through the lens of a series of platforms. So they're saying you need a customer experience platform. So very important if you're kind of Apple and you're B2C, business to consumer. You need a partner platform, for example, if you're a class society and you work with lots of different kind of partners, or at least, working with all the shipyards. And most companies need an employee platform. So basically your information systems, your email, your CAD of your shipyard, ERP, all of these kind of things. And if you deal with things, you need an IoT platform. So how do I measure the performance of the things that I'm building? So automotive manufacturers, airlines, of course, aircraft manufacturers need that IoT platform. And then in the middle, we're starting to see this all-important data and analytics platform. And this is a core part of the future of the step change in productivity that we think is possible across all of the organizations that we work with. So let's have a look at this in a little bit more detail. So first of all, is a change in architecture and organizational thinking. And we look at this information systems platform. As I said, this is typically Behind the scenes, it's your CAD. If you're a company which designs products, it's a CAD system. Maybe it's a PLM system or PDM. It's your email, of course. It's your ERP system, and it might cross over into your manufacturing execution system. Those are all of these vertically siloed applications. What Gartner is saying is you need to start to join this stuff together to be able to optimize across those different silos. So what you really need in this area is an information backbone, or so what we call an information backbone, or what's sometimes called a common data environment, right? And this is not, and this is really, the concept is quite simple. It's like at least join this information together so we can understand how it's linked. That is stage one. So you can see there my bullet point of visibility of the configuration of the business. So first, how do the processes interlock with each other? So your workflows and your business processes, but also what's the configuration of the asset, the product which I'm going to build, right? And you might say, well, that's in the CAD system and the configuration of the business is in the ERP system. Partially, yes. So first of all, some of the configuration of your product may be in the CAD system, but more than likely it's going to be in the CAD system, Excel sheets, several CAD systems. You might have one for electrical design, you might have one for your shipbuilding 3D coordination or hull and outfitting. You might have a specialist one for mechanical design as well. These are not one, single source of truth. And the same when you look at the business processes. Some of those business processes are in your ERP system, so your procurement process, for example, but not some of the manufacturing processes, not your design processes, not your bidding and tendering processes. These are external. So bring it all together in an information backbone. And doing this is not necessarily easy, but this is a key fundamental building block of digital transformation. You need to understand the configuration of the products that you're building and be able to get your hands on that information really easy, and the configuration of your business processes. Or even you need to understand the projects which you're executing in their entirety. So the second thing that we look at as a major thing is the platform for things. And this is, of course, particularly applicable to shipbuilders and ship operators. So this is the industry I'm looking at. Ecosystem, customer experience platform, I'm not going to look at just now because it's not so applicable to these industries and it's not within the scope of my paper. So a platform for things is very important if you have any physical asset in your business. So if you're a shipbuilder, of course, you have many physical assets in your shipyard. And if you're a ship operator, of course, you have your vessel and all of the assets on board the vessel. So an IoT platform is generally seen as an absolutely essential thing to have these days for these businesses. At a fundamental level, you're collecting data from a physical asset and you're storing it. So that's something which you need to do. To be honest, this is becoming a bit of a commodity. A lot of companies can collect data and store. You can do that in an Excel sheet, actually. But then you need to be able to add context to this information. So to what object does this information belong? Is this sensor, for example, a subsystem or subcomponent of a system, etc., etc.? You need to be able to share this information, which is primarily enabled by the cloud today. And of course, you need to be able to visualize and use this information to do things. So it's typically some form of analytics that you're doing when we talk about visualization of IoT data these days. So of course, Aviva acquired OSI Soft recently. It went through in April this year, 2021. And the OSI Pi system is a very famous operational data management system. It's got a very long history. It's got a very robust functionality. And this diagram really helped me to understand why the Pi system is different from other IoT platforms out there, and why it's a really, really good building block for this, this holistic optimization phase that we're about to enter in the world. So on the left-hand side, you have information from hundreds or potentially millions of what we call IOs, so input-output sources, typically sensors. And you need to connect to those sensors. And there's, I think there's about 600 protocols that we support Basically, we can get information from pretty much anything. So this information is basically flowing into what's called a data historian, so something that is it's a special database designed to store time series data. So this is basically your sensor will have a frequency at which it records a parameter, and of course you pump this into this huge database, which is very big data. It's definitely categorized as big data, and you need to make a very efficient database in order to store this data. And of course over time, right? So the Pi system does loads of things on top of that natively, on its platform. So the first thing it allows you to do is define what we call an asset framework. That allows you to define where all of these sensors belong. So first of all, what is this sensor? What kind of sensor is it? To what asset does it belong, or which piece of equipment does it belong? And then of course you might want to know that this equipment, let's say take a freshwater pump or seawater pump, belongs to the seawater cooling system, and that belongs in turn to the machinery room, etc. And that in turn belongs to the vessel called made of the oceans, which in turn belongs to the gas division of your company. So don't just think about IoT systems as something just for a single asset. Think about IoT platforms as something which is going to manage your IoT data for your enterprise. And that's a very important aspect as well. So that's why we need to say this sensor belongs to this piece of equipment, which belongs to this system, which belongs to this compartment on board this vessel, which belongs to this division of this company. You want to be able to do this across a whole enterprise at some point, and that's what the Pi system is really famous for. So asset framework, the Pi system allows you to do asset analytics, so you can basically apply some simple mathematical transforms to the data. So for example, let's sum energy usage from site 1 and site 2 together and make this into a new parameter, a calculated parameter, which is the total energy usage from this particular vessel, for example, or system. Or as you can see at the top here, we can actually smooth out data and give us an average uptime from these two assets here. The Pi system also allows you to create what we call event frames, so to mark a particular set of data between two times, so a time frame, which is basically like a kind of keyframe. So it's flagging something for either a human being to look at later, or increasingly for a machine learning algorithm to look at later. So these event frames, of course, they can be automatically generated by an algorithm which says, here is something that looks wrong. Please look at this, human, because I can't identify what it is. Or it can be a human saying, I remember something happened on this date, so I'm just going to flag it by marking, this whole day of the data. And then somebody can look at that on shore, or I can pass it through a machine learning algorithm. So event frames are very important to start to be able to use your data and flag things in this huge data set for analysis, for downstream kind of processes. And then finally, you want to be able to take these event frames, which again is kind of automatically generated or human generated, and do things with that. So usually it's notifications, it's alarms, and it's triggering workflows. So this is what a real robust enterprise operational data management system does, and hopefully you'll understand why that's a fundamental building block for digital transformation. But there's another thing I'd like to bring across, which is basically how an enterprise operational technology or operations data management system is used. So quite typically, when people talk about IoT systems, they're thinking about measuring information from a thing, so a sensor, so a pressure sensor, a temperature sensor, an RPM sensor, whatever it is. But because the Pi system is deployed across an enterprise, so very often it's deployed across all divisions, all departments of an enterprise, it makes sense to instrument everything. So the thing that kind of blew my mind was that, of course, on board a vessel today, an operating vessel, the main instrument is the noon report. So this is what every vessel has been doing for literally centuries. Somebody will go and measure several parameters, such as the wave height, the wind, the clouds in the sky, the fuel level, the speed of the vessel, the amount of power that's being put into the propeller, for example. And they will record this traditionally on a piece of paper, and they would maybe radio it if possible back to shore, or they would certainly put it into the log. These days, that noon report is still, basically kind of hand measured, or it's noted down by a human looking at some instruments in the engine room, and then it's typically emailed back to shore where it goes into a database. And that's how people start to say, okay, the fuel consumption has increased on this journey despite your weight and displacement decreasing. Why is that? These days, of course, you want to do that fully automatically, fully digitally. But to go back, the noon report, a piece of paper, is an instrument. So think about this, of course, not just in the operations of the vessel, but across everything. So if we look at the design process, we're using our CAD system. The CAD system spits out reports, which people use today. These reports are a form of instrumentation and performance and measurement of your design process. Put that into your operations data management system. The same for ERP, approved purchase orders, scheduled work packages. These are reports which again can go into your operational data management system, and over a very long term start to give you really nice information to be able to measure the performance of your business. The same for the completed jobs, rejected jobs from your manufacturing execution system. The same for the sensors of the assets in your shipyard. So what we're seeing just now is that shipyards are saying, yeah, we have, of course, some data from our robotic panel line, that they typically have a SCADA system, so a supervisory and control system in that production line. But what shipyards are not able to do is to take all of the data from their production facility and to put it up at that enterprise level and understand how the shipyard is performing. And we're starting to see shipyards wanting to tie together quality reports. So if you're getting rejected jobs, right, from your manufacturing execution system, you want to be able to tie that together with, for example, a loss of hydraulic pressure in one of your hydraulic presses, right? And you can see where I'm going with this. You can then tie it together and say, oh, this is why we're getting rejected jobs, because it's not actually able to bend the plate or the pipe or whatever it is according to the specifications. And then, of course, we're talking about shipborne assets. Then it's very straightforward. Start to measure what's going on board your vessel. Start to put this into one place, and of course across your whole fleet. And then you'll start to be able to get benchmarking information and do all sorts of interesting analytics, which I'll get onto a little bit later. So we've talked about the information systems platform as a building block, the IoT platform as a building block. What about data and analytics? Well, this is where those two things really come together. And this is what I refer to as the composite digital thread. So this is the ability to take the configuration of the products that you build. So the ships, the design of the ships, how they're put together, how they were specified, how those specifications were met through 3D objects and diagrams and systems. And of course, the actual performance of these products. And this is, of course, I'm blending things together here. So the information backbone could be, the configuration of your products, could be the configuration of your shipyard as well in your MES system. And of course, it's implicitly got an understanding of the business processes that went on in order to create this. So this is your information backbone. Operations data management, we've talked about, is generally performance information. And it's when you bring these together that you get this perfect data and analytics platform. It's only makes sense when you understand what was the configuration of the product or the production line or the process that created this performance, which I've measured with sensors and instrumentation. So that's the fundamental new thinking. This is, as far as I understand, what we call performance intelligence at Aviva. what we're able to do with all of our engineering design systems and project execution systems at the top, and what we can do with all of our operations data management systems at the bottom, the composite digital thread. In the paper, I go on to say that, of course, this is where it makes sense to apply your data governance. You actually have to do that at all of these levels. You apply some data governance here, some data governance here, but it makes sense to apply this across your composite digital thread. And this is where it makes sense to apply a common visualization platform. So the ability to access the information in here through desktop, mobile, handheld, head-worn devices, immersive devices in a common way. So that's a very important aspect, which I bring out in the paper, but I didn't have too much time to talk about in the presentation. So how do we build a better maritime industry? Well, there's a couple of things going on here. So one of the things that we're seeing is that the industry wants to streamline this onboard information management challenge and provide a basis for ecosystems to form. So as I said today, actually many operating vessels today have these data silos. You have a system from somebody like Kongsberg, a system from your engine manufacturers, MAN, Caterpillar, Wärtsilä. You might have systems for your cargo, systems for your navigation, auxiliary machinery. And those operational technologies serve those equipment manufacturers very well. In fact, Kongsberg and Caterpillar are using the PI system to do that. That's the basis of their KIM system and what Caterpillar are doing. But it's difficult for an operator to really use this information. So what we're starting to see is that operators are saying, well, let's kind of standardize here the PI system. Even if there's another instance of the PI system running for Kongsberg or for Caterpillar, let's take the information from that, put it into our PI system. And the PI system has some really good tools to allow you to actually take subsets of operational data and share it with other people, especially if you're using the cloud version of it. So we think this is going to be technically straightforward. It's a matter of the business models of all of the players aligning so that the information could be shared. And then what we start to think is a better system is that if a ship operator is controlling their operational data in a more holistic way, they can then provide access to these other players in a more consistent way. So let's say we're taking the model and we turn it around. Instead of CAT deploying their own IoT box on every single vessel where their ship is, which is the way it goes today, or certainly with Kongsberg. How about building a ship from a shipyard that already has an IoT platform on board and that is already connected through the sensors to all of the systems on board, which are going to be relevant for the next 20 years. Putting this in one place, managing it in a holistic way, and sharing it with anybody who needs to access that. So of course you need to make some of a kind of agreement with Caterpillar. When you build this vessel, it's agreed Caterpillar will have the free access to this set of data so they can do their predictive maintenance or condition monitoring program, whatever they do with the data. And they get that copy, they own it, but they're not collecting it. They're not having to go through the hassle of install their own operational technology for that. And of course, there are a growing number of startups which are building their value through analyzing data. So they don't necessarily want to collect the data. They don't want to manage the operational technology behind the scenes to collect the data, but they do want to use this data and run their algorithms on it for route optimization, generator optimization, etc., etc., etc. In fact, Schneider Electric, our parent company, is doing this with electrical systems. And you can see here that we think there's a real potential for the ecosystem to connect to the ship's PI system and to use the data for their analysis. What needs to change, of course, is the way that contracts are done. And that's not an easy thing to solve. But this is some of the new thinking that's going on. And to support that, we're working with hardware manufacturers to change the way that this operational technology is deployed aboard vessels to make it as easy as possible for a ship operator and essentially a hands-off process. So today there are a couple of ways this can be done. We can deploy what's called a data collector. This is a very, very small bit of software that's basically a database that will take data from sensors and simply store it in the database, nothing else. Typically that data, whenever you come into connectivity or if you want to use satellite communications, it can then be shared back to shore where we apply a lot more of this intelligence to the data. You do your shore analytics and you can visualize information in a more holistic way. As you can see, here's all the basic components of the shore-based. There's a more advanced option where you can deploy a full PI system on board the vessel. And this is more important if you need to do more onboard visualization or onboard or what might be called edge analytics. So again, it depends what kind of vessel is and to what degree you're doing sort of advanced analytics on board or edge computing. But that's another option where you have this PI server, so the full PI software installed on the vessel. But this needs, of course, sometimes somebody to look at that onboard software to perform a software upgrade or to change the configuration of it. So we're working again with hardware providers. We've created some new components on our software that allows that onboard edge computing to be fully configured remotely. And this is very important because A, it takes away the problem of having to administrate this software on board the vessel, and B, it allows these vessels to operate autonomously. So if you move towards vessels with even lower crew than they have today, you won't have to have somebody with IT knowledge necessarily. You should be able to remotely reconfigure your operational technology. So this is basically supporting this autonomous operations. So I'm just going to give a couple of examples of where we really think it's going, this composite digital thread. So the good way to explain how this works is with a Formula One example. So we all know today that Formula One teams are recording operational data from the Formula One cars. It's called telemetry. So it's basically recording data remotely, which is the same concept as operational technology. But let's say that Formula One car has a couple of different versions of the front wing. So they have version 1, version 2, version 2B, etc., etc. So they run some tests with version 1, and then, they replace the wing with version 2B. And then, of course, they see some, improvement in the lap times or some improvement in the grip in certain corners. And they say, great, that's fantastic. But imagine, and they would, of course, then go and optimize that 1B, wing for whatever else it needs to be optimized for. Imagine that they didn't record which wing they had changed. So they could see the operational data had improved, but they didn't know why. And that's the fundamental problem that industry needs to work on just now. We're still working on measuring the operational data from vessels, but it's going to be extremely important in the future to couple that with the configuration of the product, which is basically that part at the top, which says the ship that I'm running just now has this physical configuration. And let's also think about the configuration of the software that's running on that vessel. So we all know about Tesla or even the more traditional cars. We're able to provide a software update to that CDI chip, your control unit in a car, and that of course can fundamentally change the fuel consumption and engine behavior. And of course Tesla is the extreme example where they're able to deploy software updates to the sensors, to the battery management system, and actually improve the performance very significantly without changing the configuration of the hardware. So we need to think about this in the future. There will be changes to the physical configuration of a vessel as you add ballast water treatment systems, as you add scrubbers. There's going to be changes to the configuration of the software. So this might be where Kongsberg come in. They might change the configuration of your dynamic positioning system. Probably not something you want to touch actually, but I can see a world where you're going to push updates to the software configuration on board the vessel, and of course more in a slower frequency when the ship comes into dry dock. you will be changing the physical configuration of the vessel. Another example just come to mind is you bring your vessel in, you run a robotic robot, which was, by the way, one of the very interesting papers at the COMPIT conference, and you clean your hull, right? You want to record that your hull now has a clean hull. And that's the configuration of your product. You know, thickness of fouling equals, 0.1 or let's say 3 millimeters instead of 30 millimeters. That's the kind of product configuration that you need to store somewhere so you can then make that performance data interesting. The same thing with business processes. Let's say you change your business process and you're seeing that you're able to execute your design project more effectively. So let's say you go from paper-based drawings to augmented reality glasses in order to do your fabrication. Lovely example, right down my street. And then you see that you're actually able to produce more pipe spools or install more pipe spools on the shop floor because of this change. You now have the coupling, this is what this thing is in the middle, it's a coupling between the change in your process and the operational performance of your business. And this is what performance intelligence is all about. This is what we can do. And I wanted to kind of end with this visualization here. This is the Unified Operations Center. It's a way of bringing together all of this kind of information into one place. And it's got the concept of time can be applied to everything you see here. So you can roll back and forward in time and go back and forward on your CCTV cameras, go back and forward on your project plan at the same time, or at least what should have been done and what actually has been done. It's an amazing piece of technology that brings all of this left-hand side together in a way that at least humans can consume very well. So, in summary, IT and operational technology is typically siloed and fragmented in the marine life cycle, not just marine, but very much is the case today. Transformational change is limited by this current IT and OT paradigm. So we've kind of reached this point where we can't really optimize very effectively, at least not to make any step change. However, the commoditization of operational technologies means that we have data as a commodity in some industries like factories, oil and gas to a large extent, and marine is just on the verge of making data into a commodity. I think it will happen very quickly in the next 5 years. So there's a shift towards cloud-based business platforms, which allows this kind of collaboration, the simplification of your IT architecture. And I think the core concept here is to couple the configuration of products and businesses to operational performance data, which will unlock major optimization. So like I said, you can optimize, the whole operation of the vessel for fuel consumption. You can imagine scenarios where the paint manufacturers are able to optimize the chemical composition of their paint for anti-fouling based on data which they get back from the ship operator who can measure the fouling and the resistance based on fuel consumption and the weather and all these kind of things. So that's all from me just now. Of course, some of the concepts which I've talked about here, the coupling of performance information with product configuration, go back into this typical systems engineering V that we see. So where we've got requirements, detailed design, and then the realization of your requirements in a physical thing. And then on the right hand side, it's about performance measurement. So let's not forget that system engineering V, or what's quite often called model-based systems engineering, I think these days, which is that modern approach of taking simulation and simulating different scenarios, but then taking effectively historical data and validating those simulation results. So you're going to improve your design process through that measurement of your operational performance. Of course, it's not so easy because we've got a ship owner on the one side, equipment manufacturers, and the shipbuilder on another side. And these parties are not connected. But we think this is going to happen through the power of the cloud, through the ability to share this information. And of course, we need to come up with new contractual methods and new ways of working together. But I think we're at the verge of something really special in not just the marine industry, but in many capital intensive industries. So thanks for your attention. I look forward to your comments. If you've got any questions, please contact your local Aviva representative. You can write to me here on YouTube or at Tartansky on Twitter with your comments, or look me up on LinkedIn. Thanks for your attention, and have a great day. Bye-bye.